We are looking at, is Grep all you need? How Agent Harnesses Reshape Agentic Search by Sahil Sen and colleagues at PwC. If you are an AI researcher or an ML engineer building agentic workflows, pay attention because this one is critical.
Yeah, absolutely.
In these systems, simple lexical search like just good old-fashioned Grep frequently beats semantic vector search, especially when those results are injected directly into the context window.
Which is kind of wild to think about.
Right. But the performance isn't just about the search algorithm. It is massively influenced by the agent harness, so custom frameworks versus provider-native CLIs.
And your tool calling paradigm matters heavily too, like inline versus file-based delivery.
Exactly. So the big takeaway here is that blindly defaulting to vector search in your architectures might be a huge mistake.
Yeah, it really might.
And changing your agent framework actually impacts accuracy just as much as swapping the underlying retrieval engine.
Okay, let's unpack this. So to really understand why Grep is winning here, we kind of have to look at how far the field has moved from traditional static retrieval-augmented generation.
Right, because static RAG is basically just a straight line.
Exactly. In standard RAG, the architecture is totally linear. You get a user query, you embed it, run a similarity check against a vector database for the top results, and then
you just append those chunks to a prompt and the LLM spits out an answer.
Right. It's a one-shot process.
Yeah.
But agentic retrieval changes that fundamental architecture. It becomes this iterative loop where the model is actually in the driver's seat.
It's doing the driving itself.
Yeah. It autonomously decides what keywords to search, it evaluates the results, maybe modifies the query to run it again, and crucially, it dictates its own stopping condition.
Which introduces like a whole new set of variables when the agent is actively navigating the corpus instead of just getting a static data dump. The tools it uses to navigate become the bottleneck.
Exactly. And that brings us to the two main retrieval contenders that researchers looked at.
Right. So first up, there's semantic vector search. This relies on dense embeddings and approximate nearest neighbor matching.
Yeah, and just to be super clear on the mechanics there, vector search converts chunks of text into high-dimensional numerical vectors.
So it's doing math, basically.
Right. It calculates the mathematical distance between the query vector and the document vectors.
Yeah.
Which is amazing for conceptual similarity. Like, if the agent searches for canine healthcare, it will find documents about, dog visits to the vets.
Even if those exact words never appear in the text.
Exactly. But that fuzziness introduces overhead. You have to maintain an embedding pipeline, manage vector indexes, deal with latency, all of that.
Which contrasts directly with the second paradigm, which is lexical search. So your traditional Grep, BM25, exact pattern matching.
The old reliable tools.
Yeah, exactly. You are looking for literal strings of raw text, byte for byte. It is computationally cheap, highly stable, and requires zero embedding infrastructure. I mean, if I could offer an analogy here, vector search is like sending an intern to a massive library to find books on a specific theme.
Oh, I like this.
They are going to bring back an entire cart of books that are conceptually related to your prompt. But Grep is like giving that same intern a laser pointer and saying, find me this exact serial number on this exact page.
Yeah, and if you already know the serial number, that laser pointer is just infinitely faster and more precise.
Exactly. But the rules of that library completely dictate how well the intern can use the laser pointer.
Which brings us to the agent harnesses, the environment enveloping the LLM.
Right, and the PwC researchers tested two very distinct architectural environments.
Yeah, so the first is a custom harness. They specifically use an open source framework called Chronos. And Chronos is really built for long horizon memory tasks using the React paradigm.
And for anyone who hasn't implemented it recently, React stands for reasoning and acting. It forces the model into a structured loop.
Right, so instead of just generating a final response, it generates a sought trace.
Like, I need to find the user's purchase history.
Exactly. Followed by an action command to a specific tool, and then it gets an observation back. And Chronos takes that loop and really optimizes.
It gives you a lot of control, right?
Tons of control. It allows developers to use dynamic prompting, so the instructions shift based on the task state. It also runs parallel routines for structured event extraction, pulling out explicit timestamps and dates.
So it's highly deterministic. The engineer has fine-grained control over the context window.
Exactly. But then on the completely opposite end of the spectrum, they tested provider-native CLIs. So we were talking about Cloud Code, Codex, and the Gemini CLI.
Right. These are basically terminal shell interfaces wrapped around the foundational models.
Yeah. They give the model direct execution access to standard bash utilities. So native Grep or else, or cat right out of the box.
But the trade-off is that they are essentially black boxes, right?
Total black boxes. The developer completely loses that fine-grained control over prompt engineering. You're relying entirely on the provider's opaque internal orchestration.
Okay, so we have the search algorithms and the harnesses, but we also have to talk about the delivery route.
Right, how the data actually gets handed back to the LLM. The paper looks at two architectures for this. The first is standard or inline delivery.
Where it just prints straight to the screen.
Exactly. The standard output of the search is printed directly back into the conversational context window as the next message. It's simple. It's immediate.
But it causes what we call context rot.
Yes, because LLMs have finite context windows. Even if you have a 200,000 token limit, injecting massive walls of raw text degrades the attention mechanism.
The window just gets crowded with noise, and the model starts forgetting its original system instructions.
Which leads to the second delivery route, which is programmatic or file-based delivery. So instead of dumping the output into the chat, the environment writes the results to a temporary file on the disk.
So the agent just gets a tiny message saying, like, results saved to tmperp results.txt.
Exactly. And that saves a massive amount of context bandwidth. But it introduces programmatic indirection. The agent cannot actually see the data yet.
Okay, so with that setup, clear semantic versus lexical search, custom versus native harnesses, inline versus file-based delivery, let's look at what actually happens when you run this.
Right, a benchmark.
Yeah, they use a 116-question subset of long Meval. And just to ground this for the listener, long Meval tests an agent's ability to recall facts over multi-session chat logs.
Right, so imagine a user chatting with an AI over 60 different sessions spanning months. In session 4, they say their dog is named Buster.
And in session 42, they mention a vet appointment.
Exactly. So the benchmark asks, what is the name of the pet the user took to the vet? The agent has to retrieve the right sessions, connect the entities, and answer.
And the baseline findings here are just wild. With inline delivery, Grep universally beat vector search.
Universally.
Across every single harness and every single model tested, lexical pattern matching outperformed dense embeddings.
The gap is massive, too. If you look at Chronos running Google's Gemini 3.1 flashlight with inline Grep, it hit an 86.2% accuracy rate.
That's solid.
But when they swapped to inline vector search, that accuracy plummeted to 62.9%.
Wow. And it's not just the search tool. The harness shifts the ceiling, too. Like Claude Opus 4.6 hit 93.1% on Chronos with inline Grep.
Right.
But that exact same model dropped to 76.7% on the Claude Code CLI harness.
Yeah. The data proves you cannot evaluate a foundational model in isolation. You are evaluating the model plus harness as a single entangled system.
Wait, if inline delivery crowds the context window and causes context rot, shouldn't programmatic-like file-based delivery be the obvious fix to boost scores?
I mean, that is the exact assumption a lot of architectural teams make. But the data shows it is a massive trap.
Really?
Because for many models, moving to programmatic delivery causes performance to just collapse. You have to look at what file-based routing actually demands of the agent.
It's trading context bandwidth for a multi-step workflow test, right?
Exactly. You are no longer just testing if the model can retrieve text. You are testing its ability to operate as a Linux system administrator.
Oh, because the agent still has to take a second action to access that file?
Precisely. Let's trace it out. The agent runs the search tool. The environment saves the file and returns a path. Now, the agent must output a secondary command like cat tmpresults.txt.
And if the file is huge, it might need to use head or run grep against the text file itself.
Right. It has to ingest that stream, integrate it into its reasoning, and potentially loop again if it didn't find the answer.
That's a lot of friction.
It is. Look at the Codex CLI running GPT 5.4. With inline grep, it scored that impressive 93.1%, but switched to programmatic grep. It crashed down to 55.2%.
The model just completely lost the plot trying to execute that read, integrate, retry loop.
Yeah, it had the intelligence to synthesize the answer, but lacked the navigational competence to extract the data reliably.
So the theoretical benefit of a pristine context window never even materialized because the workflow itself was just too brittle? Now, given that long Meval rewards highly specific, literal, facts-like dates and names, it makes sense why grep dominates the inline format here.
Because semantic search is fundamentally fuzzy.
Right. In multidimensional space, Buster the dog and Fluffy the cat are practically overlapping. If the agent runs a semantic query for user's pet, the vector search brings in every single session mentioning any animal.
It creates this dense, noisy dump of what researchers call topical false friends.
Yes, topical false friends, whereas Grep surgically extracts the literal date or fact, ignoring everything else.
And weaker foundational models like Claude Haiku 4.5, they just lack the attention heads to navigate a dense vector dump full of those false friends. They get so distracted.
So Grep is brittle-like. If you misspell a word, you get 0 results, but when it hits, it's highly concentrated.
Exactly.
But that makes me wonder about scale. Grep is the ultimate laser pointer for a static data set, but in production, databases grow constantly. Does that lexical precision hold up when you flood the system with noise?
Well, this brings us to the stress test the PwC researchers ran. They dynamically varied the per-question session limit to see how the algorithms degraded under scale.
How did they set that up?
They established baselines at 5 sessions, which they call S5. Then they scaled the noise up to 10 sessions, 20, 30, and finally the full haystack, which was between 39 and 66 distinct chat sessions.
And they always kept the Oracle sessions, the logs with the actual answers in the mix, right?
But as the limit increased, they just injected more and more irrelevant distractor sessions.
So the noise in the environment just gets progressively louder.
Right, and what the data reveals is this really nuanced crossover effect. On average, Grep consistently outperforms vector search as noise scales. But vector is actually incredibly strong at the lower session limits, like S5 or S10.
I would assume that's because at lower limits, the bundle of data is still small enough for the model to process entirely.
Exactly. The vector search easily maps the neighborhood of the topic, and there just aren't enough false friends available yet to overwhelm the context window.
It buys you early, robust coverage.
Yeah. For instance, Kronos running Claude Opus 4.6 peaks on vector search at the S10 limit. It hits an impressive 94.8% accuracy.
But then what happens at S30?
The sheer volume of topical false friends starts to poison the context window, and that vector accuracy drops sharply to 84.5%.
Wow. While Grep's trajectory behaves totally differently. It isn't perfectly smooth. It bumps around depending on how the distractors match the rejects patterns, but once it finds a pattern, it reliably separates the needle from the haystack.
It holds steady at high noise levels precisely because it ruthlessly filters out anything that doesn't literally match.
Here is where it gets really interesting, though. We have to talk about vendor-specific cultural defaults.
Oh yeah, this might be the most critical finding for practical enterprise applications.
Because as they scaled this noise, the researchers noticed wild divergences based entirely on the vendor stack being used.
The data is so clear on this. Claude Code consistently favors Grep. Whether you run the heavy Opus model or the lighter Haiku model, the Anthropic CLI environment naturally performs significantly better with lexical search.
But the Gemini CLI exhibits the exact opposite bias.
Yes. It consistently favors vector search for Gemini 3.1 Pro. And that performance gap actually widens as the haystack gets bigger.
Right. At the full haystack level, the Gemini CLI hits 89.7% for vector retrieval versus only 78.5% for Grep.
Which forces us to reevaluate what a tool actually is when you deploy it in an agentic system. When a developer deploys Grep in a production CLI, they aren't just deploying a primitive C-based algorithm.
They are deploying Grep plus the shell environment plus the hidden system prompting.
It's the entire ecosystem under the hood. The provider tooling introduces deep inductive biases into the model's behavior.
So the CLI dictates the default hints the model gets.
Exactly. It dictates how the standard output is chunked. It determines how tool errors are surfaced back to the model. It even establishes cultural defaults in how the CLI agent naturally phrases its bash commands.
Which means you absolutely cannot take an agentic workflow that is highly optimized in Claude Code, migrate it over to the Gemini CLI, and expect the same retrieval behaviors.
You really can't. Even if the text files on your server are byte for byte identical, the stack will behave completely differently because of those hidden biases.
You are adopting the provider's philosophy on search, whether you intend to or not.
Exactly.
So synthesizing this for the technical folks listening, the AI researchers and engineers building these systems. Do not treat your agent harness as passive infrastructure.
It is not just a neutral pipeline.
No, it's not. Your choice of environment, whether you build a custom React harness like Kronos or rely on black box provider CLIs, and your delivery method, choosing between inline context injection or programmatic routing, that actively dictates whether semantic or lexical search will win.
You have to evaluate the retrieval mechanics, the orchestration prompts, and the delivery path as a single, heavily entangled system.
Which leaves us with a rather profound question about the current state of AI evaluation.
Yeah, it really does. Because if a foundational model's ability to find information is so heavily dictated by the cultural defaults of its CLI environment, like Claude Code's preference for Grep versus Gemini CLI's preference for vector search,
Right.
what are we actually benchmarking?
Right.
When we run these massive tests, are we actually measuring the AI's inherent reasoning intelligence? Or are we simply grading the effectiveness of the vendor's hard-coded shell scripts?
That is the perfect thought to leave you with. Thank you for joining us for this deep dive on AI paper podcasts. We hope this challenges you to fundamentally rethink your default or pre-architectures. Until next time, keep questioning the defaults.